So, hello students, I welcome you all in the lecture series of artificial intelligence and machine learning for business prospects. Okay. So, here I will be discussing on lecture 12, okay, and the lecture 12 is based on the model evaluation in machine learning, is not it? In machine learning, you have created so many models with the help of SVM, with the help of KNN, with the help of several other techniques that are the comes under the categorization of the supervised technique, because supervised lies under the machine learning. This is the categorization of the machine learning, is that clear? So, model evaluation, what you have created the model, whatever you have created the model, whether it is accurate or not, your model will be accurate. You have to calculate it, you know, whether it has created it's a good or right or wrong, good or bad, you know, on the basis of some technically accuracy, precision, recall. These are the terms that you will calculate that your model is that you have created is good, right. Okay. So, you have to find out. So, for solving, for analyzing, for doing all that, this you know, here confusion matrix will help you to solve this all. So, how basically it works and what basically it does, I will cover here in the topic in this slide. Is here as you all know that what machine learning exactly and what model evaluation in machine learning, it will be discussed here. So, machine learning is all about here that will allow to computer to gain insight from data and experiences just as a human being would. Okay, just as a human being, you have created your machine on behalf of you, on behalf of the person, machine will act accordingly. Or whatever you will give the command, machine will act, machine will work, right. And which obviously machine learning is the latest and prominent technology, and obviously it is just a subset of artificial intelligence, right. And it involves constructing mathematical model. Why mathematical model? That will help to understand the data at hand, okay, what exactly it is. So, basically our goal is to create a model that will, but the model, your basic goal of has to create the model, but your model should be the high quality, should be the high quality model with promising predictive power. You have to create the model, but in a high quality and promising predictive power, that should be over accurate. Accurate, yes, it should be over and it should be promising accurate, okay, predictive power it has the capability. So, what machine learning is? Basically model, how it is developed, it's all will be discussed here. So, model evaluation in machine learning, basically you have provided the training data set, you have provided the observational data, and these data are the, why these are the labeled data? Because they are the supervised, they are given by some supervisor, they are, it is given by a supervisor only. So, you have to be given the training data that you will use for the model evaluation. And model evaluation is the core task to perform in machine learning over workflow. Okay. So, it is basically the process through which we quantify the quality of a system predictions. Is that clear? How you will quantify, it will be discussed here. To do this, we measure the newly trained model performance on a new and independent data set. Is that clear? So, basically in the continuation of that thing, I will discuss here the confusion matrix. Confusion matrix will helpful to identify these accuracy, these over accuracy. Okay, you have whatever model has created, you have to be just to find out its accuracy, precision and all. How you will calculate, it will be discussed here. The model that you have created, this model should contain true positive, true negative, false positive, false negative. What does it mean? Okay, see, basically it is works, obviously the prediction, there will be one value that is predicted by someone, and there will be a value that should be the actual value, and you have to compare those actual value and predicted value, that whether it is correct or wrong, correct or not. If it is very much close to the actual value, then it is okay, and if it is not actual very much close to the actual value, that it is incorrect. So, you have to match corrected or predicted, actual or predicted, that will be how you will see it all. You will be see on the basis of this true positive, true negative. True positive means when you are predict an observation, when you are predicting your observation belongs to a class, okay, and it actually does belongs to that class, that should be the same, that predicted and actual should be same, that means true positive. Yes, you are saying right. True negative means actually it is true, but predicted false. Is that clear? You can see with this matrix also. Suppose these matrix you have created for the 100 samples, 100 samples of data you have to given, and what are the goal is, your goal, suppose you are trying to create a model, you have to create a model that can predict the result, right, for the disease, that is either a person has the disease or not, person having a disease or not, you have to predict. How you will predict the person, whether the person having a disease? Suppose there are 100 samples are given, 100 samples are given, right. So, I am taking 100 sample, this particular things, here it is predicted yes or no, and here it is actual yes or no, here it is actual yes or no. So, suppose predicted means person is going to be, person is going to check the disease. So, if the person is having the disease, yes, predicted is yes, and actually the person is having a disease, no. This is false positive, true positive, false negative, true negative. How, why it is false positive, why it is true positive? Since actually predicted is yes, yes, this should be happened, this should be, this is the predicted things, okay. So, predicted yes, yes, predicted yes means this is positive, positive, but why it is F and why it is T? Actually you have predicted you have a disease, this is positive, okay, and actually it does not having a disease, this is false, actually it does not, because it is lie under no section. So, actually it is, it do not have a disease, he do not have a disease. So, that means they are not matching, right. Predicted yes, you are having a disease, and actually they do not have a disease. So, there are the contradiction, yes and no, na. So, here F is added. So, FP, and here predicted is yes, you have a disease, you have a disease, this is predicted value, and actually they do not have a disease. In actually here do not have a, or here you have a disease, yes, actually you have a disease and predicted you have a disease, both are matching, right, both are matching, that means both are positive and true. So, here you will write true positive. Why it comes in this category, what are the categories, isn't it, is that clear? Why it is written here FP, TP, FN, TN? FP means false positive, whatever you have predicted, you have, this is the predicted area and this is the actual area. Predicted means you have predicted something, yes, you have a disease, you have predicted you have a disease, and actually they do not have a disease. So, predicted yes, first you will write just PP here, and why you will write F and T on the basis of it is predicted P, and you will see in this area this is no, na, actually no. So, this yes and this no are contradictory each other. So, here it is written F. So, this is FP, this is TP, that is FP and TP is written here, I am explaining here FP and TP. True positive, true positive means true positive are when you are predicted, and when you are predicted an observation belongs to a class and it actually does belongs to that class. So, true positive will comes. True negative are when you are predict an observation does not belongs to a class, okay, true negative does not belongs to a class and it accurately actually does not belongs to the class, then this is true negative. False positive, positive is also said to be the type 1 error. False positive is also said to the type 1 error, and it occur when you predict an observation belongs to a class when in reality it does not. When in reality it does not, that is false positive. Reality may know, and but predicted yes. False negative or type 2. False negative is said to be the type 2 type of problem, and type 2 error, and it occur when a predict an observation does not belongs to a class when in fact it does. Okay. So, what does it mean? I will be shown you. Now, confusion matrix, confusion, that was the confusion matrix that I have shown previously. So, confusion matrix is what? It's just a kind of matrix set, okay, matrix used to determine the performance of the classification model for a given set of test data. Whatever the data is given, suppose you have here I am taking the 100 sets of data, right, that is given, and that data is categorized into the matrix manner, okay, and matrix manner, and there are some terms that you will use for solving that particular things, whether it is accurate or not. So, what the terms is, how it is works, it will be discussed here. It can only be determined if the true value for the test data are known, okay, and the matrix itself can be easily understood, but they are related terminology may be confusing, since it shows the errors in the mode performance in the form of a matrix, hence also known as error matrix. Okay. So, confusion matrix in machine learning is what? Basically, why it is used? It evaluates the performance. Confusion matrix will do what? Confusion matrix evaluates the performance of which? Of classification model, okay, when they make prediction on test data and tells how good our classification model is, okay, how good our classification model is. So, confusion matrix not only tells the error made by the classifier, but also the type of errors, such as it either type 1 or type 2 error. Okay. And with the help of the confusion matrix, we can calculate the different parameters. Okay. Then after you will able to predict the thing, your model is accurate or not. You will predict, you can calculate the different parameters. What parameter is? Such as accuracy, precision, error rate, recall, etc. These parameters are calculated. But how you will calculate these parameters? It will be discussed here. See, suppose what I have told you in the previous, we can understood the confusion matrix with this example also. Suppose you are trying to create a model that can predict the result for the disease, that is either a person has the disease or not. So, the confusion matrix will solve that. How, what confusion matrix will do? Confusion matrix is given here. Confusion matrix, first you will, the matrix is divided into two dimensional. Matrix is divided into two dimensional, predicted value and the actual value. Here I am taking the predicted value, here this side I am taking the actual value, and the table is given for two classes classifier which has two predictions, yes or no. Here yes defines that patient has the disease, and no defines the patient does not has the disease. Okay. So, how you will calculate? Here predicted is that yes, patient has the disease, and here in actually it does not has the disease. Suppose here I am taking the 100 sample for that, and 100 sample, this is FP is 3, TN is 65, FN is 8 and TP is 24. Okay. The whole about yes or no, the predicted value will be 73 plus 27 becomes 100 and 68 plus 32 becomes 100. This is all on the 100 type training data set, 100 samples that I have taken. So, what TN, TP and FN, FN and TN, FN, FP and TP, what exactly it Is that clear na? So, how you will calculate, the accuracy, how you will calculate the precision, whether the model is saying right or wrong. So, there are some formula for that calculations. We can perform various classifications for the model. Accuracy is what? Accuracy means Tp plus Tn upon the whole sample, how much you have taken. Okay. Tp plus Tn, Tp plus Tn is what? Here Tp means this predicted yes and actual yes, both are matching, that is why the Tp, true positive, and Tp plus Fp means predicted yes and actual no, that is Fp. Okay. Tp plus Fp. So, here the formula accuracy contains Tp plus Tn. So, here this is Tp and Tn is what? Predicted no, actual no, that is why both are true na, just remember Tt, Pn. So, accurate means they whatever they are saying here, they are saying it is predicted yes, here actually yes, predicted no, actually is also no, both are true, that is why you will take the accuracy here. Accuracy means Tp plus Tn divided by the whole sample, this the whole, so then it is 100. So, how you will calculate the accuracy? Tp plus Tn, that means 65 plus 24 divided by 100, that means you have gotten 0.89. Your model is very much close to the 100%, that is 0.8%, not 100%, 0.8%. Yes. So, the model is accurate on the 0.89 manner. Okay. You have created how much error rate is this then? You have seen if it is 0.89, that means how much error rate is 0.11, but accurate bus error rate, how error rate is calculated? Fp plus Fn, Fp plus Fn, Fp means this is, you have predicted yes, and actually no, error na, predicted yes but actually no, error, you have taken this value, you have predicted no, it will not happen, and actually it is yes, there is also contradictory each other, with the contradictory na, these two terms are contradictory. So, both are having an error, that is why you will take this value here for calculating the misclassification rate, or you can say it also error rate. Error rate means Fp plus Fn divided by the whole prediction, how on the whole sample. So, 3 plus 8 divided by 100, that is 0.11. Is that clear? So, what precision is, how much precision it, precision and recall both are same. In precision you will take only the value, in precision this Tp and Tp both will be divided by, this will be only Tp plus Fp, Tp plus Fp means Tp plus Fp, this is predicted yes, this is predicted yes. In precision Tp by predicted yes, how much predicted yes is, how much predicted yes is this. Okay. So, you will take the precision with the help of this formula Tp by Tp plus Fp, Tp by predicted yes 24 by 7, and in recall Tp will be same, but here is just difference that actual yes, here predicted yes, here actual yes, and actual yes is what, how much, 32, this is 32. Okay. So, recall after this particular time, every time you have to recall, you have to find out the precision, you have gotten your error rate, you have taken the accuracy with the help, whatever the model you have created, that will be calculated on the basis of these parameters. Okay. So, again I am saying, again I will focus on this particular slide, what exactly is for creating model when performing classification predictions, these 4 types of outcomes could occur. What it is? True positive, true negative, false positive and false negative. That means, true positive are that when you predict an observation that should be belongs to a class, your prediction, your observation is belongs to the class, and it actually does belong to that class also. It actually does belongs to that class. That means, true positive, yes, you are true and you are right. Yes, true negative are when you predict an observation, and does not belongs to a class. True positive predicted, yes, but does not belongs to a class, and it actually does not belongs to, that means true negative. Is that clear? False positive is also the type 1 error, maybe error na, false error. Type 1 type of error is said to be the false positive, type 2 kind of error is said to be the false negative. So, false positive is what? False positive occurs when you have predicted an observation belongs to a class, when in reality does not. Okay. And false negative is type 2 error, and it occurs when you predict an observation does not belongs to a class, and when it fact it does, in fact is does, that is the false negative. So, what are the term and why it is introduced here for solving the confusion matrix? I hope it will be clear, right? So, confusion matrix is all about to confuse. Why it is used? It is used to determine the performance of the classification model for a given set of data, right. The data will be supervised, data is the labeled data, because you all are discussed here the supervised learning, and supervised learning is the classification of the machine learning, and supervised means supervised class learning, supervised classification is the also categorized classification and regression. So, supervised and machine learning, they are provided the labeled training data set. Okay. So, training data set is labeled and it is given by the supervisor. So, you have to calculate some things, some technical terms, you have to determine if the value is true or test the data that are known. Okay. That should be just test only with the help of these parameters. Okay. So, the matrix itself can be easily understood, but the related terminology are confusing. So, it has already it has clear by you, I think it has been related with the term that is given in the example. Okay. So, since it shows the error in the model and there may be a error na. So, what error is exactly it, and this error is said to be the error matrix, okay, or how you will calculate it, it is also clear, I think. So, basically confusion matrix in the machine learning, I am repeating you, it evaluates the performance, obviously it predicts the things that is the given, and given is what, that is the test data that is given, and it will tell that it is how much good our the classification model is. It is good or bad, you can decide on the basis of these parameters. Okay. If it only tells the error made by the classification, but also the type of error, such a type of error is type 1 or type 2. Type 1 error or type 2 means if it is tell the error made by the classification, and with the help of this confusion matrix you can calculate the different parameters that you have seen in the previous in this slide. Okay. So, confusion matrix is all about you will calculate, just you will divide your dimensions in the two manner, predicted value and actual value. So, predicted value, actual value, on the basis of this you can say that your model is good or bad. And why model is created? Model should be created just for checking the things, how it will be looks like in the future, and what would happen if what would be the resemblance, it is all checked by this. That is why you have created the model. Model should be first created, and as you have seen in the support vector, in KNN classifier, in the decision boundary, once you have created the model, it just checked it. The data is checked by every steps, and after that final touch you will just say that your prediction is right or wrong. So, these are several techniques that you have seen here. In supervised learning, that is all supervised by somewhere. Supervisor will supervise you, supervisor will guide you, that is why it is all the comes under supervised learning. And we will see in next unit the unsupervised section, there will be a lot of things that will be solved with the help of the unsupervised learning also, but supervisor is there. So, your training data set should be accurate, right, that your supervisor is there, that means whatever you have done in the model, but what model you have created, that is accurate. If supervisor is there, na, the things should be accurate, the things should be in a proper manner, right, in the smooth manner it should be run. So, that since supervisor is there, so these things are have whatever you have created, it is also checked by somewhere, something. So, confusion matrix, some terms are confusing, as the name suggests, confusion matrix. So, confusion matrix will solve your confusion, whether it is created, whether the particular model that you have created is right or wrong. Is that clear? So, the table is given for these two classifier, these are the basis on this, yes or no. Here yes means the patient, here I am taking the example in the terms of the patient, whether the patient having a disease or not. So, if the patient having a disease, that means the model will say yes, and if it does not have the disease, that your model said no. Okay. So, the confusion matrix, TP, TN, FN, FP, what exactly it and how it is, why it is, it's had been clear by you, I think. So, confusion matrix will help to solve these following terminologies: accuracy, misclassification rate means error rate, and precision, recall. These are the terms that you will calculate after creating the model. So, model evaluation will help you to avoid many unhappy incidences, so that in future you will not be bothered about all that, whatever you have done, the model will help you. So, these model evaluation, every aspects will help you. Okay. So, model evaluation will help you to avoid many unhappy incidents on the way to machine learning. You have to train the machine, your machine should be accurate. So, at every aspects you have to check it out, you have to find out the accuracy, whether it is correct or wrong. Okay. So, model evaluation will very much helpful for finding this, for evaluating all that. Okay. So, supervised learning is classification, and whatever you have classified and whatever you have created the model, whether it is accurate or not, these following terminologies are helpful. Okay. So, I hope this slide, this lecture will helpful to understanding the model evaluation, the classification purpose, in the supervised learning. This is all about the types of the supervised learning in machine learning. Okay, machine learning, supervised learning is one of the type. So, how model evaluation is helpful, I hope it will be clear. So, thank you so much. I hope this will like you.